Hello, everyone, and welcome to another episode of Innovation Impact Makers, where we meet people quietly making an impact in innovation. The recent war with Iran made it clear how dependent we are on energy and how easily it can be cut off. My guest today, Omer Hiram, is working on a solution to the topic. His startup, Ion Flux, is developing the means to deliver hydrogen on demand. Welcome to the podcast, Omer.
Thank you, Naftali. Thank you for having me.
My pleasure. This isn't your first time working in hydrogen, so can you explain how you got into the area?
Yeah, sure. I'm a chemical engineer by trade. I worked industry for over 20 years in oil and gas. And my last job in the field was production manager of Door Chemicals in Haifa, which is a major producer of hydrogen in Israel, 80% of the market. And I learned through my feet, going through the motions and running the systems, running logistics, and the nitty-gritty of the real job in high pressure and in a very high, I would say, high risk environment.
Explain the attraction behind hydrogen. What is so good about hydrogen?
Well, if you look at the pros, hydrogen is perfect. It burns with clean, with no emissions actually. The burning of, or the oxidation, which is burning of hydrogen, produces water. So anything you do to get energy from hydrogen, you get the energy, if it's heat or expanding gases, etc., and water, which is basically a zero tailpipe emission system, whichever way you go, which means for any users or any place you're going to work, you're going to be neutral to the environment, which is a big plus. Hydrogen, of course, has a very high energy density per mass, per kilogram, much higher than batteries or any other fuels that we know. So everybody really wants to use it, especially regarding green and...
So this begs the question, hydrogen's been around for a long time. Why isn't it in such mass use up until now?
Well, the other side of the coin is, of course, the dangers that we have with hydrogen. It's a very flammable, explosive gas, and the molecule is very small, so it's very hard to contain inside pressure vessels or through valves and piping. So you've got a very good, very clean, very energetic fuel, but it's really expensive to hold on to. And the cost of ownership and the safety issues are just push people away. And this is, of course, before taking into effect what we call the Hindenburg effect, that everybody remembers, that Zeppelin that blew up almost 100 years ago, and that goes with us as a society.
What are some of the means that are used to bring hydrogen, to store it? What are some of the things that have been looked up until now? Before we go into Ion Flux's unique way of doing things, what are some of the methods that have been used until now, and what are the advantages, disadvantages?
Well, hydrogen is mainly produced in chemical plants as what we call gray hydrogen from hydrocarbons, which means you produce it in a plant and you pressurize it into tanks to haul it or to transport it to where you need. And this is, of course, very expensive and very dangerous. Bottom line is you haul a semi truck that can haul 30,000 liters of diesel, for example. It can only bring you about 250 or 300 kilos of hydrogen, it's like 1/8 of total energy.
How is that stored? Is it gas? Is it liquid?
It's a compressed gas for most applications to high pressure, 300 bars and 300 times the atmosphere that we're used to here on Earth, or liquefied, which means it goes to minus 253 Celsius.
Which that's how to use it for launching rockets, right?
For launching rockets, for if you want to transport more mass, then they liquefy it and transport it as a liquid. And this is, of course, even sometimes more dangerous and, of course, more expensive, because you put a lot of energy into compressing the gas itself or liquefying it. So any one of these ways that you wanted to go, you had a lot of overhead, a lot of safety concerns. And bottom line is you couldn't do it anywhere you'd like, because regulations say you can't store that much hydrogen, say, in a regular gas station, if it's going to be inside the city or near populated areas. And this is a major gap or interference with this economy that's been promised for, like you said, 20 years.
Many years ago, in one of my previous careers in General Motors, this is back in the early 2000s, we were looking at hydrogen and storing it in a more stable way. We were looking at metal hydrides. What can you say about that?
Well, metal hydrides are in use today. They're used for storage in high-end uses, mainly
What what
submarines today.
what are they so everybody knows?
Well, Vision is a sponge made out of very active metal that when you introduce the hydrogen to it, it actually bonds to the metal. So you have a sponge kind of taking in the hydrogen and holding it in that way in low pressure. So that's a very good solution. But you get like 1.5% energy mass, which means for every 100 kilos that you carry of hydrogen, you can carry about 1.5 kilo of hydrogen. Just to get around the numbers, 1 kilo of hydrogen is 100 kilometers of drive in a regular, let's say, family car.
So you have to hold about 400 kilos of added weight onto the car just to be able to go any range that's normal, correct? Okay.
Exactly. And not to mention, it's very expensive, and you have to have very, very ultra clean hydrogen so you don't contaminate the hydrate, et cetera, et cetera. It's not such a simple occurrence.
So let's get into what you're doing to solve the any challenges with it. What is Iron Flux doing and why is it different? How is it different? And how did it get started?
Okay, so I'll start with the last question because it relates to all the rest and to what we talked about before. Actually, working in the industry and doing some operations that required hauling large amounts of hydrogen, I realized that the magnitude of work, of safety precautions that we have to take just to move a few trucks from point A to point B means that it will never get to regular, day-to-day civilian use as we're used with regular fossil fuels just because it's too dangerous, just because you need very trained personnel. And the price, of course, if you haul, let's say, 250 kilometers worth of car travel in one, that's what we said, 250 kilos in one semi truck, the economics don't work out. It's too expensive. If you look at hydrogen prices at the pumps in the United States or Europe, 80 to 90% are just of the price is just related to the logistics, not the manufacturing. And this is exactly what we're going to solve, or what we are aiming to solve, because we're looking at this whole problem upside down in our company. Instead of carrying hydrogen around and trying to make it safe, we don't have any hydrogen on board until the moment we need it. We carry the energy, our fuel, our aluminum, which extracts the oxygen from water to release the hydrogen, is a solid metal. So you have very good, very safe, very stable logistics with very good energy density. And in fact, logistics don't see any hydrogen at all. It's only produced when, like I said, the moment you need it. And the systems themselves are designed to work in very low pressure, which is typically 5 to 10 bar or atmospheres, if you like. And this is
So
the lowest grade of in the safety standards. This is a very, very low pressure, very manageable. And of course, bottom line, you don't have a lot of hydrogen on board anyway. So even if the worst happens, you don't have big explosions or fires.
I want to do a one-to-one comparison of what you mentioned before, but beforehand, just so everyone understands, if you think about the way I was introduced to this is if you think about a coffee maker and you have these little capsules that you put into the coffee maker, these capsules contain aluminum. And then, as I understand, you introduce water, and then hydrogen comes out of the capsule until it's depleted. Is that the correct way of understanding?
It's a very good example. Thank you for bringing that up. Yeah, if you remember 20 years ago, you have to go to a coffee shop if you want a nice cup of coffee. There was a barista there. He was a trained personnel we were talking about, and he had a big machine with a high pressure espresso maker so he could get the pressure up and give you the good coffee you like. And you would carry that boiling cup of coffee in a paper cup to wherever you want to go. This is a one-to-one comparison to what hydrogen looks like today. But we don't do coffee that way anymore. We have an espresso machine with capsules in our office. And you want a cup, you just drop a capsule inside, mixes the water with the coffee, and you get a premium cup of coffee without, or whenever you like, without carrying a big espresso machine with you. So it couldn't be a better comparison in my eyes.
So you mentioned previously that you need about 250 kilos, which 250 kilos for a truck percent.
That's what a truck can haul. That's what a truck can haul because
So let's do a comparison of something simple. You mentioned it takes several hundred kilos in order to give a car or some kind of vehicle the range it requires with the hydrogen. Because up until now, I understood it about 1.5% of what you store it in is actual hydrogen. What is there now, and what are you doing differently that's much better that gives you more percent hydrogen?
so again, if we look at our numbers, think about you would go to a gas station and you would we used to have Xerox machines, copy machines in our offices. Once in a while, you had to change the toner, right? So there was a big cylinder you would pull out and put one back in. This is the refueling. This is what our refueling is going to look like. Actually, in our demonstrator, this is exactly how it looks like. You have a cylinder filled with aluminum fuel. We call it ALF, activated aluminum fuel. You would take out the used pod, put it in the recycling right at the station, put a new one in, and fill water in a different tank, and you're set. From there on in,
Why do you need to go to a station?
well, you could have it at home, of course. You could stockpile this at home, and it's very safe to keep. This is one of the big pluses, as long as it's in a dry environment. You don't need special tanks. You don't need battery containment devices for the dangerous materials there. But most people, if we envision it or we compare it to using a car today, to the same user experience, then yeah, you go to a station or you go to your Costco where you can exchange your, much like SodaStream refill bottles, you bring the empty or the used one and you pay just for the refill. And this is the same business model here.
You could basically offer it through retail, just buy the capsules for what you have.
This is very close to the business model we're thinking about. I don't really want to go into that because the technology is very exciting here, and I want to bring that forward. I will just say that there is a strong business model behind this.
How much hydrogen can you give per capsule? Like you mentioned 1.5%. How much more are you providing this way?
Well, we have 11 power density or energy density, which means for every 9 kilos of aluminum, we get 1 kilo of hydrogen. Like I said, 100 kilometers of drive, and for every kilo of aluminum, we need a kilo of water. But this is regular water. This is not distilled, not special magic water that
So about 20 kilos of hydrogen and water in order to.
no, 18 kilos of aluminum plus water for 100 kilometers of drive.
Okay. So typical range for cars about 400. So you need
Let's
about.
say 500. You need 45 kilos of mix. Yeah.
So you're gonna need about 100 kilos
Oh,
total.
sorry, 45 kilos of aluminum and 45 kilos of water. Yeah.
Yeah. So that's a much less. It's about 75% less than what you mentioned before.
Yeah, but if you look at batteries,
Yeah.
we're at, including the water, we're 4.5 times more energetic per kilogram, which means if you have a 200 watts hour, this is big, people get lost in these numbers. But if you take the 1 kilo of batteries and 1 kilo of our mix, you would go almost 5 times farther with your car.
So you're also thinking about charging batteries on the go and doing some kind of hybrid
Of course,
application.
this is we've seen this today in current technologies. Hybrid electric cars are considered the best way to go. They balance out the best of both worlds. If you have short drives, you just work on the battery, which can be recharged off the grid. Or if you wake up in the morning and there was a power outage, you still have a gasoline motor today to actually charge those batteries on the fly and keep driving. So just change out that gasoline powered engine with our technology, with hydrogen, let's say fuel cell for, this is what we're looking at. This is the best known technology today. And you would get essentially a range extender that is also zero tailpipe emission, and you get that same green, no non-polluting system.
So Influx is a startup. So assuming that you get all the funding and everything all the development goes smoothly, what are the applications and more or less the timeline? What products will be coming out and what timeline from using your technology? Just give us an idea.
We're looking at 2 years to market give or take. This is depending on the situation, the global situation. But we're talking about a 5 kilowatt system, which is essentially a generator that can be plugged into a vast array of solutions or needs. Depends on what side of the table you're on. Anywhere from charging vehicles or range extenders if you want to charge on the go, off grid for construction sites, for people who want to live off the grid or have problems with the grid they live with. And I'm going to mention, of course, the military market, which is craving for energy in the field. We have very modern armies today, very digitized, even the optics on the guns themselves, on the personal weapons are electrified already. The soldiers in the field need a lot of electricity, and this issue is still open. To date, they just use batteries.
So before, it's very, very interesting, but what are the manufacturing implications? How easy is it to make this aluminum? What kind of aluminum? Is it difficult?
Well, once you know how, it's very simple, like many things. The type of aluminum that's used this has been looked into and investigated. It doesn't matter. The aim is to bring finally scrap or recycled aluminum, which is very cheap and it's a product that's already has its own ecosystem. You can tap into that. And our thinking is to melt it into the form we want, into the size or the flakes we want. We have a treating process that activates it, and then you just pack it dry in a capsule, and it's ready to go.
Are you looking to be the manufacturers, or are you looking to
No,
other manufacturers?
we would like to partner up with major business and major players in the field. This is not when you're talking about energy, and I've seen this happen, it's too big a market for a small startup company. You just don't have the volume for it. So any major players, especially if they work with aluminum, but if they want to dip into energy or hydrogen, this could be a big deal for them.
Very
I would
interesting.
just also, sorry, OEMs and tier one, tier two producers for the auto industry, because they move so much aluminum, because they have so much spill-offs and offtake that they are responsible for. This could be a very good business for them.
For actual recycling, you mean?
Yeah, recycling on site, you could actually power your own operation with the scraps you have laying on the floor instead of paying a lot of money. And this is also a regulation issue to move it to somewhere else for recasting, remelting, or whatnot. Or God forbid, the Far East, and just give that energy to a different country.
Very interesting. Omer, thank you for explaining how this works. I'll certainly be following it.
Thank you for your time.
Appreciate you joining us today.
Thank you.